Lesson 12.1, Introduction to Limits. Consider a function f of x and a point on the function. This point is CL. A limit is if the function becomes arbitrarily close to a unique number L as x approaches C from either side, then the limit of f of x as x approaches C is L. So in other words, as we travel along the function towards this point, towards where x is C, so x is getting close to C, then y is getting close to L. That is all it's saying. The limit as x approaches C of my function is L. So L is the y value. So as your function's x value gets close to C, the limit is saying the y value just gets close to L. And we're talking close, close, infinitely close. So we have a couple ways we could find limits. Here's one way is we could use a table. So let's find the limit of this function, the limit as x approaches -2. Well, if we were to plug in a -2, we'd get 0 divided by 0. And 0 divided by 0 is completely undefined. We'll learn more about that in the next lesson. So what we could do is make a table. Notice though the table is somewhat logarithmic. So here I'm 1,000th off, then 100th off, then 1/10th off, in the same way in both directions. So here's the 2, the -2. And so I go both above and below it, but I go by powers of 10. So when I plug in -2.1 into the function, I get -0.1. When I plug in -2.01, I get -0.01, and so on. So you can see here, well, what is this getting close to? This is getting close to, between the negative and positive is going to be 0. So it's approximately 0. There are 3 limits that fail to exist, meaning there is no limit. First one is x approaches different numbers from both sides. So here, if I wanted to find the limit as x approaches 0 in this case, from the left, the y value is -1. From the right, the y value is +1. Well, it can't be both -1 and +1. Second one is this one here. If they just keep going up and up and up and up and up forever, infinity is not a number, so that limit doesn't exist. Or the last one, we oscillate between 2 fixed values, such as cosine of 1 over x. So you zoom in closer to closer here at 0. For all of these, we're doing the limit as x approaches 0. There's just more and more and more and more oscillations between +1 and -1. And so you can't tell what it is, because the more you zoom in, the more oscillations there are. So the 3 limits that don't exist. There's some properties of limits. The limit of a number equals the number. So this is saying the limit as x approaches whatever of 2 is 2. I mean, if the function's always a single number, then it'll stay that single number. The limit as x approaches c of x is c. So essentially this is saying, oh, we could just plug in the c and see what we get. Same thing here. If we have exponents, we could still just plug in whatever x is approaching. And this one also, assuming it's defined. If it's undefined, of course, then it won't have a limit. What if we have 2 separate limits? We could combine them. If we multiply a function by a number, we could just multiply the limit by that same number. If we add or subtract two functions, you can just add or subtract the limits. If you multiply two functions, you can just multiply the limits. If you divide two functions, you can just divide the limits. And if we have an exponent on the function, just put the exponent on the limit. So let's evaluate some limits. All right, we could use the table, but the tables are kind of long. We could try, first of all, just plugging it in. So it'd be 3 times 2 squared. Order of operations says we do the 2 squared first, which is 4. 3 times 4 is 12. So the limit as x approaches 2 of 3x squared is 12. How about this one? Well, we could try plugging in the 1. Everywhere where there is an x, put the 1. 1 cubed is 1. 1 squared is 1. 4 minus 2 is 2, plus 17 is 19. And our last one. Let's go ahead and try plugging the 2 in. So we'll have 2 squared minus 4 over 2. So it gives us 0 over 2, which is 0. 0 is a fine number.